Hello, my name is Gerson Vanegas. I'm with my partners MARGIE PALLARES and TANIS PINEDA. I'm going to talk about distribution to students. The objective of this video is to analyze the characteristics and application of the distribution T of students, which contribute to our professional training. The distribution T arises in most of the practical statistical studies, when the typical deviation of a population is unknown and must be estimated from the data of the sample, and that the sample is less than 30. It is similar to the normal curve, but the distribution T has greater area to the ends and less in the center.
Functions. Its functions are based on establishing a confidence interval, using a level of trust and degrees of freedom, obtaining values from a table with respect to these variables and applying them in the formula. It is very useful to reduce time, cost, and effort. It is used to test hypotheses and also to know if two samples come from the same population. Uses for which this distribution is suitable. First, to determine the confidence interval within which the mean of a population can be estimated from small samples, it is to say n less than 30. Second, to test hypotheses when an investigation is based on a small sampling. And last, to test whether two samples come from the same population.
Degree of freedom. There is a different T distribution for each one of the possible degrees of freedom. What are the degrees of freedom? We can define then of the number of values that we can choose freely.
How to differentiate it from other distributions? The distribution T is similar to the distribution T, as both are symmetrical around an average of 0. Both have time distributions, but T is more variable because they have fluctuations in two quantities. The distribution of T differs from the T in that the variance T depends on the sample n, and is always greater than 1. Only when n tends to infinity, the two distributions will be equal. Problem 1. ACME Corporation manufactures light bulbs. The CEO claims that an average ACME light bulb lasts 300 days. A researcher randomly selects 15 bulbs to test. The sample bulbs last an average of 290 days with a standard deviation of 15 days. If the CEO's statement were true, what is the probability that 15 randomly selected bulbs will have an average lifespan of no more than 290 days? To solve this problem, the first thing we need to do is calculate the T statistic based on the following equation, where x is the mean of the sample, mu is the average of the population, and s is the standard deviation of the yn sample, which is the sample size. Now we are ready to use the calculator T distribution. As we know the T statistic, we select T-score from the random variable drop-down box. Next, we enter the following data. Degrees of freedom are equal to 14. The T statistic is equal to 0.7745966. The table shows the cumulative probability 0.226. Therefore, if the real life of the bulb was 300 days, there is a 22.6% chance that the average bulb life of 15 bulbs selected will be no more than 290 days.